Good afternoon, respected chairpersons, distinguished scholars, and fellow participants. It's a great honor for me to present our research today. My name is Marzuki from Universitas Al Muslim, and I am collaborating with Hasratuddin and Sumarno from Universitas Negeri Medan. So the title of our study is the self-concept of elementary school student and learning material through 4C-based problem-based learning. This study lies at the intersection of mathematics education, affective psychology, and 21st century learning, particularly in the context of Madrasah Ibtidaiyah or Islamic elementary school. Our main focus is not only on how students learn geometry cognitively, but also on how they perceive themselves as a learner, which we refer to as self-concept. Now let's move on to the background of the research. Um, Geometry is often considered as one of the most abstract and difficult topics for elementary school students. Many students struggle to visualize shapes, understand spatial relationships, and apply concepts to real-life situations. However, the issue is not purely cognitive. From our observation and previous studies, we found that many students develop a negative self-concepts, meaning they perceive themselves as not good at mathematics. And this perception leads to low confidence, reduced motivation, passive classroom participation, and ultimately lower academic achievement. Another important issue that the traditional teaching method tends to be teacher-centered, focusing heavily on procedure rather than meaningful understanding. As a result, students often fail to connect geometry with real-life context. Although problem-based learning or PBL has been widely promoted as an innovative approach, most studies focus primarily on cognitive outcomes. The affective dimension, especially self-concept, has not been sufficiently explored. To address this gap, we integrated 4 skills: critical thinking, communication, collaboration, and creativity into PBL. Therefore, this study aims to answer the two main research questions. Number one is whether the 4C-based PBL significantly affects students' self-concept and learning geometry. And the number two is whether there is a significant difference between students taught using 4C-based PBL and those taught using conventional PBL. Let's move on to the theoretical framework. This study is built upon two interconnected theoretical foundations. First is self-concept in mathematics. Self-concept refers to how students perceive their own abilities and value in specific domain, and in this case is mathematics. We operationalize self-concept using 5 indicators. First, self-confidence. Students believe in their ability to solve a problem, and the number one is self-acceptance, their ability to accept strengths and weaknesses. And then the third one is self-esteem, their sense of worth in learning mathematics. And number 4 is independence, is their ability to learn and solve problems autonomously. And number 5 is positive social interaction, which is their ability to collaborate and communicate effectively. And research shows that students with a positive self-concept tend to engage more actively in learning, perceive when facing difficulties, and achieve better learning outcomes. On the other hand, a negative self-concept often leads to anxiety, avoidance, and disengagement. And the second is we adopt 4C-based problem-based learning. PBL emphasizes student-centered learning through real-world problem when enriched with 4 skills. Number 1 is critical thinking, which is help students to analyze and evaluate problems. Number 2 is communication, where it will encourage them to express ideas clearly. And number 3 is collaboration, where allows them to work effectively with peers. And the last one is creativity, which enables them to generate innovative solution. By integrating these elements, learning becomes not only cognitively engaging, but also emotionally and socially meaningful. Let's move on to the research method. We employed a quantitative research design, specifically a pretest post-test control group design to examine causal relationships. The participant consisted of 54 grade students selected through post-process sampling from a Madrasah Ibtidaiyah or Islamic elementary school. They were divided into 2 groups. Number 1 is the experimental groups, consisting of 25 students who was taught using 4C PBL, And the second group is the control group, also consisting of 25 students who start using standard PBL without explicit 4C interrogation. To measure the outcomes, we use two instruments. The first one is a geometry post-test to assess cognitive achievement, and number two is self-concept questionnaire, which was carefully validated and aligned with the 5 indicators mentioned earlier. Uh, for the data analysis, we follow several steps. Like number one is we tested normality using the Kolmogorov-Smirnov test, and the second is we tested homogeneity using Leibniz test, and the last one is we conducted an independent sample t-test with a significant level of 0.05. This procedure ensured that our findings are statistically reliable and valid. And let's move on to the result and discussion. From the descriptive statistic, we can see that the experimental group achieved higher mean scores than control group in both geometry performance and self-concept. More importantly, the inferential analysis reveals statistically significant difference. For geometry achievement, the t-value was 2.79 with a p-value of 0.0075, and for self-concept, the t-value was 4.30, and we reject the null hypothesis. Since all p-values are lower than 0.05, we reject the null hypothesis. This indicates that the Fusi PBL model has a significant positive effect, particularly on students' self-concept. Interestingly, the effect size appears stronger in the affective domain than in the cognitive domain. This suggests that when the students are actively involved in discussion, collaboration, and creative problem solving, they not only understand the material better, but also develop a stronger belief in their own abilities. In other words, learning becomes both intellectually and emotionally empowering. Let's move on to the conclusion. Based on the findings, we can draw several conclusions. First is the 4C-based PBL model significantly improves both student geometry learning outcomes and their self-concepts. Second ones, all 5 indicators of self-concept like confidence, self-acceptance, self-esteem, independence, and social interaction showed meaningful improvement. And the third, the study confirmed that effective learning should address both cognitive and affective domains simultaneously. In terms of recommendation, for teachers, we strongly encourage the adoption of 4C-based PBL, especially in teaching abstract topics such as geometry. For curriculum developers, it is important to explicitly integrate 21st century skills into curriculum design and assessment framework. And for researchers, future studies should explore different educational level, subject areas, and also examine long-term impacts through longitudinal research. And finally, I would like to express my sincere gratitude for your attention and participation. We truly appreciate the opportunity to share our research with the distinguished audience. If you have any question or comment or question, I will be very happy to discuss them. Thank you very much.